Today we're going to look at some more special types of quadrilaterals. Charlie Brown's favorite, the kite. And we're also going to take a look at trapezoids, and in particular also isosceles trapezoids. Take a look at those properties and apply what we know in different problems with those shapes. So let's first of all take a look at those properties on GeoGebra and explore what it looks like, and maybe we can determine some of those properties that they have. So let's first of all take a look, and you can explore these on your own if you want to explore these with more time. I have the links on the website. So let's look at a trapezoid in general. What do you see about that shape? What do you notice about it? As we drag it around and change the shape, maybe you notice that sides don't all appear to be the same. But angle measures, as we look at those could all be different. Side lengths. Side lengths aren't always the same. Slopes of sides. I see these two sides have the same slope. Remember, if sides have the same slope, they're parallel, so pair of parallel sides. Let's see, angles from the diagonals. I see that this one is the same, but these aren't, so there's maybe no connection there. Let's see, what else can we find? Diagonal measures. Diagonals aren't the same. Each part of the diagonals. Once again, they're different again, so nothing really there with the diagonals. And the angle measures, those are supplementary. So the trapezoid can be called isosceles trapezoid, kind of like an isosceles triangle. You notice that it has the same properties, that it's like these two sides are parallel, same slope no matter what I do to it. Side lengths. Notice we have two side lengths congruent, just like an isosceles triangle. And when we look at angle measures, these base angles are congruent. Angle measures with the diagonals. A lot of information there. It's a little confusing. We'll just move on and look at some of these other properties. Diagonals are congruent. So that's what makes the isosceles trapezoid different from the regular trapezoid. And let's take a look now at the kite. Okay, so as I drag the kite around, we can look at it different properties. No matter what I do to this shape here, diagonals always bisect, or are always 90 degrees. And this shorter diagonal is bisected, no matter what I do. Opposite angles, these two are congruent. These two are not, but these angles are bisected by this diagonal. And so those are a couple of properties of the kite. We can shrink it down, make it look like a diamond a little bit, but maintains that 90-degree diagonal, bisected, opposite angles. These opposite angles are congruent, and these are bisected. Okay, so let's take a look now at how we can prove figures, if they're trapezoids or kites, based off of that information. Let's put some of that information down in our notes as well. So trapezoid we talked about is a quadrilateral with exactly one pair of parallel sides. Parallel sides we call the bases, the other two we call the legs. It has two pairs of base angles, AD and BC. So the non-parallel sides are the legs, as we mentioned. So how would we prove that this is a trapezoid? Well, if we're going to do that, we have to apply those properties of trapezoid. We need one pair of sides parallel. So why don't you take the time to calculate the slopes of the sides. Remember, if sides are parallel, they have the same slope. So let's compare opposite sides, RS and OT. See if those are parallel. And let's also compare slopes of RO and ST and see what those are. And because if both sides are parallel, then it's a parallelogram. But if only one side is parallel, then it's a trapezoid. So pause the video, calculate those slopes, and we'll check that in a moment. Okay, so I did my calculations. RS is up 1/2. OT is up 2 over 4, which simplifies as a half. Slopes are the same, so lines are parallel. RS is parallel to OT. RO has an undefined slope, it's vertical. ST goes down 2 over 2, which simplifies as -1. Those slopes are different, so they are not parallel. So since one pair of opposite sides are parallel, ORST has to be a trapezoid. As I mentioned, the isosceles trapezoids, the two legs are congruent, and the base sides are parallel. The other thing we take a look at in those isosceles trapezoids, those base angles were congruent. So if congruent base angles, we know that it's going to be an isosceles trapezoid. And an isosceles trapezoid also has congruent diagonals, as we also saw on GeoGebra. These are important things to remember and take note of. Another thing we want to take a look at is what's known as a trapezoid mid-segment theorem. So we'd like to take a look at what happens when we draw or create two midpoints of the trapezoid. And if we connect that, known as the mid-segment, similar to what we did when we had the triangle mid-segment, and see what properties we have when we look at the lengths of those and go through that. So if we change the length of the sides, notice what happens. And we keep these two sides, the base sides, parallel. And notice the legs are split in half, they're bisected. What is true about these side lengths? Can you see a connection between these? I see that it appears that EF is the average of these two. And it appears that they are all parallel. Can you see why that might be true? As we take a look at what we learned with our triangle mid-segment, why would that be true? Well, isn't this just, if I were to continue these lines, wouldn't that form a triangle? It's not a very good triangle, now is it? So if I were to form that triangle, it's not a whole lot better, but anyway, we know that this is going to be broken down proportionally. And if it's proportional, remember we talked about that side splitter theorem, that if we split the sides proportionally, so this side we see is split in half, and this side is split in half, we see that these are just split down that same way. So that trapezoid mid-segment theorem that will apply shows that this line will be parallel to the other two base sides, and it's going to be the average of the two sides of the trapezoid. So as we apply that, let's take a look at our notes now. As I just mentioned, parallel to the base and half the sum of the lengths, so the average of the two, because it's halfway in between. So in the diagram, MN is the mid-segment of triangle PQRS. Find MN. Well, PQ is 12, SR is 28, so it's going to be half of 28 plus 12, the average of that. So 28 plus 12 is 40, half of that is 20. So this will be 20 inches. Let's see, add 8, add 8. So it's halfway in between there, so it'll be half the length. And finally, let's take a look at kites. Kite is a quadrilateral that has two pairs of consecutive congruent sides. These are consecutive sides are congruent. These consecutive sides are congruent. But opposite sides are not congruent. So that's how it's different from, say, a parallelogram or a square. So if it's a kite, we talked about its diagonals are perpendicular. We saw that on GeoGebra. We also saw that one pair of opposite angles was congruent as we drag that figure around. So if we look at this kite, they actually put a real kite in there. That was nice of them. And we want to find measure of angle D. Well, we know that this angle up here is 124, and this angle is 80. And it's a quadrilateral, so there are 360 total degrees. And I know if it's a kite, I'm going to have one pair of opposite angles congruent. And you can't see that pen very well. So angle D we'll call X, angle F we'll call X, And we have 124 up here and 80 down here. Since these two are not congruent, that means these two have to be congruent. So we can call this x and x. So x plus x is 2x plus 124 plus 80 will equal 360 degrees. So if we add those together, 2x plus 204 equals 360. And I can subtract 204 from 360 to get 154. And divide that by 2. And I get 77. So each of those angles would be 77 degrees. So today we looked at two other special quadrilaterals: the kite, consecutive sides congruent, one pair opposite angles congruent. And we also looked at the trapezoid and its friend, the isosceles trapezoid. One pair of sides parallel, and when it's isosceles, the two legs are the same. Base angles are congruent in the isosceles, and diagonals congruent. So apply each of those properties in your work for today.